Hello students, welcome to Instrucko's Maths class. Today's class is for students of age group 8 to 11 years. In today's class, we will understand what is place value. So, I will like to discuss our learning objectives before we can move forward. In this lesson, we will understand what a place value is, why is it important, how to write the place value of a digit in any number, and also vice versa. How to write the number if the place values of the digits are given to us. Before we move any further, let's understand the basic concepts of this chapter. So if you look here I have these single cubes that are shown to you. They represent the ones digit. The line that is shown to you, that represents the tens digit. The square plates which are shown to you, they represent the hundreds digit. And finally, the cube represents the digit at the thousand place. As you can see, you have a similar diagram in front of you at the screen. So if you look here carefully, this block, single block that is drawn here, represents the ones digit. This block here represents the ones digit. Now, when you combine 10 such blocks, we get tens digit, which is also represented by a line. Now, when we combine 10 such lines, we get a square board. This represents the hundreds digit. And now, when we combine 10 such square boards, we would be getting a cube, which represents the thousands digit. Okay, let's continue. So here we can see that 10 single blocks or 10 ones have combined to give us 1 tens. So just looking at this, we can conclude that 1 tens is equal to 10 ones. Okay, similarly, now if you look here further, you can also see that 10 such lines combine to give us 100. Thus, we can conclude that 100 is equal to 10 tens. Okay, similarly, 10 such boards combine to give us 1000. So, using this, we can conclude that 1000s is equal to 10 tens. Okay, keeping this in mind, let's understand the further slides. So here you can see how will my digits between 1 to 9 be represented. 1 will be represented with the help of one single block, 2 with the help of 2 blocks, and so on up till 9, which is represented with the help of 9 single blocks. As soon as our number of blocks changes to 10, we get a 2-digit number. Thus, that helps us in making a tens. Now here you can see that 9 single blocks were there. 9 single blocks were there. When we added another single block to it, it became total 10. So 10 is the smallest 2-digit number. 10 is the smallest 2-digit number. Now let's see how we will represent the greatest 2-digit number, which is 99, using these blocks only. So as you can see, 99 will be represented by combining 9 lines of tens and 9 single cubes. This is how the greatest 2-digit number will be represented. Now, if we add one single block to it, we get 100, which is also the smallest 3-digit number. Now, let's see how we can represent the greatest 3-digit number using these blocks. What is the greatest 3-digit number? The greatest 3-digit number is 999. Correct. So see, now in the greatest, to represent the greatest 3-digit number, we will need the hundreds also, right? Because it is 900. So first we took 9 single sheets of squares, which represents the 900s. Then 90 will be represented in the same way like it was represented in the previous slide by using 9 tens, and to represent 9 ones we will take 9 single cubes. Now if we add one single cube to it, it gives us the smallest 4-digit number, which is 1000, and thousands, as I told you, is represented with the help of this block. Now let's see how can we represent the greatest 4-digit number, which is 9999, using the help of this blocks. Yes, you're correct. We would represent it by using 9 such cubes, which will help us to write 9000. After that, to represent 900, we would again take the same 9 square sheets like this, and then to write 99, we will take 9 tens and 9 ones. This is how we can proceed in our number system. Now let's continue with our slides. Now let's come to the meaning of place value, which is the name of our chapter as well. So when we start from the right, our first column represents the ones, our second column represents the tens, our third column represents the hundreds, and fourth column represents the thousands. We can continue further also. After thousands, we get 10,000s, but we will see that in our future slides. For now, let's see how we can write the place value of the digits. So let's take this number for example. Our number is 1245. Say I have to write the place value of the digit 5. So as we all can see that 5 is at the ones position. So to write the place value of any digit, we multiply the digit with its position. So since 5 is at the ones position, we multiply 5 by 1, which gives us the place value of 5 as 5. Now let's come to the second digit, which is 4. So as all of you can confirm, 4 is at the tens position. So to write the place value of 4, I will have to multiply it with 10, which would give me the place value of 4 as 40. And just looking at this place value, I can say that 4 is at the tens position. Similarly, 2 is at the hundreds position. So to write the place value of 2, I would multiply it with 100, which gives me the place value of 2 as 200. And finally, to write the place value of 1, which is at the thousands position, I multiply that 1 by 1000, which gives me the place value of 1 as 1000. So this basically should sum up how we can write the place values. Okay, now let's come to a few activities. So as we have already understood the meaning of these images, now let's see which numbers are these digital representations telling us. Okay, so as you can look for the first example, the number of square boards is 3. So what will this imply? This implies that my digit at the hundreds place, because square boards represent the hundreds, right? So this implies that my digit at the hundreds place is 3. Now let's look at the lines that we have. So we have 1, 2, 3, 4, 5 lines here. These 5 lines represent that my digit at the tens place is 5, and we have 4 single cubes. Thus my digit at the ones place becomes 4. So my number represented by the first set of images is 354. Now here, as you can see, that there is no thousands, no representation of cube here. Therefore my 1000 digit becomes 0. And the value of 0 before any number is nothing. So the number will still remain the same. Okay, let's continue. Let's come to a more difficult question. Let's take the example 4. Okay, now here you can see an additional design. That design is of the cube. So which means in this number we have the thousands digit as well. So as you can see, there are two cubes in front of me, which means my thousands digit, which is represented by the cube, is 2. And let's come to the hundreds digit then. 1, 2, 3, 4, 5. So my hundreds digit would become 5. Similarly, my tens digit would become 4. And my ones digit would become 2. So this representation is giving us the number 2542. Easy enough and very interesting also. Okay, let's wrap up this exercise. Let's do one more example before that. Let's solve the example number 6. So now here, as you can see, that the thousands digit, I have 3 cubes, which means 3 is my digit at the thousands place. At hundreds, I have 4 square sheets, so my digit at hundreds place becomes 4. 4 is also my digit at tens place, and my digit at ones place becomes 3. Thus, example 6 is telling us the number 3443. Now, before we move forward, let's do example 5 also, as there is some interesting observation which I just made in this. So here, as you can see, we can clearly conclude that there are two cubes, which gives me 2 at the thousands position. Then there is one line which gives me 1 at the tens position. And there are 4 single cubes which gives me 4 at the ones position. Now, what about the hundreds position, since it is not represented in the image? So whichever position is left out in the image or not represented, we mark that position as 0. So that is why the number in the fifth example becomes 2114. Now, before we continue, let's revise this concept of place values and understand that in detail just once more before we proceed to our further exercises. Okay, this time we'll be using a different example. So as you can see in front of you, I have straws. Okay, so this is a bundle of, okay, let's start from this one. These are 6 single straws. Okay, then here right next to it we have 2 bundles of squares. How many straws are in these bundles? 10 straws. So we have 2 bundles of 10 straws, and then if you continue you will see that we have 10 bundles of 10 straws. Okay, so here only it could tell you that the first straw in which 6 is written represents the ones, because there are 6 individual straws and each straw represents ones. Now, if you move forward to the second one where we have 2 bundles of 10 straws, this represents the number at the tens position, because there are 2 bundles, which means there are total 20 straws, and the place value of the digit 2 is also 20. So we will place digit 2 at the tens position. Now, coming to the last image, in this last image you can see that there are 10 bundles of 10 straws. So 10 multiplied by 10 is 100, which means that my digit at the hundreds position becomes 1. I hope this concept is thoroughly clear to you, because we'll be using this concept in our further exercises also. Okay, now let's come to the second exercise. This is actually very interesting. Okay, so here it basically 20, 100 cupcakes, 500 donuts and so on, 500 tens and so on has been given to us. Now we have to convert 20 hundreds into a number. So what do we do to convert 20 hundreds into a number? Very simple. We will multiply the digit 20 with the place value again. So here in this case, the place value is hundreds. So we multiply 20 with hundreds. So if 20 is multiplied with 100, you get 2 and 3 zeros. So thus my number becomes 2000. So 20 hundreds cupcakes means 2000 cupcakes. This is a very interesting observation because this will tell you that there are various ways to write a number. 20 hundreds and 2000 is exactly the same number, but as you can see here, it has been written in two different ways. Similarly, let's try to conclude the numbers from the further images also. So here it tells me 500 tens. Now what should I do again? Again the same method. We will write the digit 500 as it is, and just in place of tens we will multiply it with a 10, which would give me the number 5 and 3 zeros. So 500 tens is also equal to 5000. Okay, let's continue. Now we have 200 ones. This is the easiest. We don't even need to multiply because any number multiplied by 1 will remain the number only, will remain the same number only. So 200 ones is equal to 200. And let's see what 50 tens is. Again 50 multiplied by the position, which is 10, which gives me the number 500. Interesting, isn't it? How one number can have so many different names. Okay, let's continue. So now we will study the numbers till lakhs. So as we have already discussed, first comes ones, then comes tens, then hundreds, and then thousands. After thousands, we have 10,000s, then we have lakhs, and finally we have 10 lakhs. So as you know, in ones, the number of 0 is 0. Basically, there are no zeros. Okay. In tens, we have 1 0. In hundreds, we have 2 zeros. In thousands, we have 3 zeros. In 10,000, we have 4 zeros. In lakhs, we have 5 zeros. And in 10 lakhs, we have 6 zeros. Now, anytime we write a number as per the Indian place value system, we have to put commas in it. The first comma comes after 3 digits. Okay, so here as you can see, the groups have been specified. So the first comma comes after the ones group. The second comma comes after the thousands group, and the third comma will come if the number is greater than lakhs after the lakh group. So basically, let's say I have written a digit here. I have written a number here. My number is 1, 2, 3, 4, 5, 6, 7. Now, how will my placement of commas be? So, my first comma will come after the 3 digits or the ones group, which would be here. My second comma would come after the thousands group, which would be here. And my third comma should, if the number had exceeded, came here. But since my number is only this much, then I only need to put 2 commas. I hope this is clear. However, in the international place value system, it's slightly different. So in international place value system, the comma always comes after 3 digits. So let's say the same number 1, 2, 3, 4, 5, 6, 7. I have to put commas in this as per the international place value system. So my first comma will come after the ones group, and my second comma would come after the thousands group only. But here the thousands group have three subparts. One is the 1000, second is the 10,000, and the third is the 100,000. Okay. Let's continue. So in our last slides, we had studied till the largest 4-digit number, which was 9,999. Now if we add 1 to this, we will get the smallest 5-digit number, which is also 10,000. As you can see here, after thousands comes the 10,000. Okay, if 10,000 is my smallest 5-digit number, then you can very well guess what my largest 5-digit number is going to be. Yes, it is going to be 99,999. Correct. Okay, now same. Let's move to another interesting exercise now. Okay, so this is a very easy exercise. Still, we will solve a few questions from this exercise. Okay, so now it says what is the place of the digit in red. Okay, so we have to mark the place value of the digit in red. So since 5 is at the ones place, its place value becomes ones. Here the place value of 5 becomes thousands, and so on. Okay, till the largest place value that we'll be learning in today's class is 10 lakhs. Okay, or lakhs or 10 lakhs. Can you tell me what is the place value of 3 here? So we have ones, then tens, then hundreds, then thousands, then 10,000s, and last the place value of 3 here becomes lakhs. Okay, let's continue to our next exercise. Now again we have to write the digits at the place value which is given to us. So here the place value that is given to me is thousands. So can all of you tell me what is the digit at the thousands place? Yes, it is 5. Similarly, let's take a bigger question here. So here if you see 10,000, my digit at the 10,000 place is 0. Now can you tell me what will be the place value of this 0 at the 10,000 place? What did I tell you? Let's revise it again. So to calculate the place value of any digit, we multiply that digit with the place on which it is. So this 0 is at the 10,000 place. So anything multiplied by 0 will give me 0. So which means the place value of this 0 becomes 0. Okay, now this is another interesting observation about the place value of 0. No matter 0 is at which place, it may be at ones, it may be at lakhs, its place value will always be 0. Okay. Now, let's do one more question before we move forward. Here it is asking us to write the digit at the lakhs place. So, ones, tens, hundreds, thousands, 10,000s and lakhs. So, my digits at the lakhs place is 9. Okay, let's continue with our other exercises. Okay. Now here, we would learn another important concept called place value. Now, sorry, called face value. We already did place value. So, as you know, the place value of any digit is the digit multiplied by its place. Now, what is the face value? The face value is the digit itself. So, no matter my digit is at whichever place, my face value will always be same. Okay, let's take an example. Let's look at the first number, which is 72,539. In this, I need to write down the face value and the place value of 2. Let's start with the place value. As we just discussed, to write the place value, we write the digit, which is 2, and multiply it with its place. What is the place of 2 in 72,539? Yes, it is at the thousands place. So we will multiply 2 with 1000, which gives us the place value of 2 as 2000. But face value is actually much easier because it is not affected by the place of the number. So no matter 2 is at whichever place, its face value will always be 2. Easy enough? Okay, let's do one more example to make sure we understand the meaning of face value and place value. Now let's look at my second number. My second number here is 51,320. So as I said, the face value is just the digit. So the face value of 5 becomes 5. And what will be my place value of 5 here? It will be 5 multiplied by its position, which is 10,000. So, my place value of 5 becomes 50,000. Right? Okay, let's do one more question. Let's do the fourth example here. In the fourth example, my number is 8,79,802. So again, my face value here will be 8, but my place value here will be 8 multiplied by its position, which is 1 lakh. And how many zeros are there in 1 lakh? 5 zeros, correct. So the place value of 8 here becomes 8 lakhs. Okay. Now let's come to the last example, which is 44,24,904. In this, my face value and place value both are going to be same. For a simple reason, of course, it's 0. So the face value will be 0 and the place value will be 0 multiplied by its position, which is 10, but again 0. So another interesting observation that we made here is that no matter whichever position 0 is at, its face value and its place value will always remain the same, 0. Got it? Okay. Let's move to a newer exercise. Actually, this exercise is quite interesting and it covers all the basic concepts that we have learned so far. Okay, so here it tells me 5 tens, and in this exercise I have to carry over and complete the given expression. Okay, now what I need to do here is can look at 18 ones. Do you think that I can break 18 ones in terms of tens and ones? Correct. And what would it be? What would it be? It would become 1 tens and 8 ones, right? I already have 5 tens here. If I add one more tens to it, now my total number of tens become 6. And what is my remaining number of ones? Because 10 ones I have already shifted to tens. So what will be my remaining number of ones? 8 ones. Very good. Now you can see here that these are just two ways of writing a same number. Both the ways would give me the same number only. 6 tens plus 8 ones would give me the number as 68. And here also, if you look 5 tens, which is 50, plus 18 ones, which is 18, would have again given me the number as 68. So what you can observe from here that we did not change the number. We just represented it in a different way. I hope you've understood what we need to do in this exercise. Let's do one more question here to understand that clearly. So, in the second example, as you can see, I have 5 tens and 26 ones. Now, how can I break 26 ones? Obviously, I can see that there are 2 tens here and 6 ones. So let's carry over these 2 tens to the other 5 tens, which will make my total number of tens as 7s, and the number of ones that are left will be 6. Again, if you check here, both the arrangements will give you the same number only. Okay, these are just two different ways of representing that number. See, 7 tens plus 6 ones would give me the number as 76, and similarly 5 tens, which is equal to 50, plus 26 ones, which is equal to 26, would have again given me the number as 76 only. Okay, let's do few bigger examples to clear our concepts. Let's come at example number 6. Here I already have 122 tens and I also have 35 ones. So again, 35 ones could be broken into 3 tens and 5 ones. When I add the given 3 tens to my other tens, my total number of tens become 125 and my total number of ones become 5. Good. Now let's come to the 7th example. Here we have 287 tens and 10 ones. Now this is so interesting, right? Because 10 ones is equal to 1 tens. This 1 tens will be shifted here with the other tens, thus making my total number of tens as 288. And we have nothing left at the ones place. So how many ones do we have? We have 0 ones. Now if I have to write this representation in as a number form, it would become 288 tens. So 288 multiplied by 10 plus 0 ones, which is 2880. I hope this exercise is clear to everyone. I will see you in my other class and we will discuss another chapter. See you guys. Have fun. Have a good day. Bye.